So welcome back to this second part. So, well, ChatGPT actually did not such a bad job, right? So I had to fix a few more typos, and you see we have the face, and it has like two strange arcs. So the placement of the arcs are wrong, but that's already something to start with. So first, we are going to kill one of the arcs because actually we just need one arc, and we are going to change the thickness of the line actually. So that's how we are going to have like the handle of the pad, not pad. So here I'm actually using this with a thickness. We can put the thickness and see, and this draw style I am putting it. Where am I putting it? I think the draw style is added to the axis separator. Okay, so it is added to the add child to the line directly, right? To the line and to the okay. Well, let's do something similar. So draw style, line thickness, let's put 5 maybe, I'm not sure. And let's create an arc. And so the arc, it should go from, so let's see what has it made. Center X, center Y, radius, start angle, end angle. So I think the start angle and end angle are correct. But if we look at that, okay, no, they are not correct. It should be rather 0 and 180. And then we have like the center. So the center, let's think we have a cube, we have a box like this, and basically the center, it's in the middle of the top edge so it's like 5 and 2.5. 2.5 on X and 5. So let's try that. And then radius, let's put a radius of maybe 2.5 is going to be too short, maybe 4. Let's try like this, see what happens. No, I'm not adding the style to anything, so that's not going to work. Wait. Let's leave it here and just put the style in arc. Add child. Increment can be adjusted for smoother arcs. Okay, because in coin the arcs are drawn from lines. Okay, that's complex, let's say. Look at that. Why is it looking weird like this? Yeah, it almost looks like a lock pad, right? It's just first the line looks weird. It's not plain, it's like rusted. It looks kind of rusted. Maybe this is the style that I'm using, like this. Maybe I can remove that. But then the position is still not correct. The center looks like it's 4. Yeah, the center is 4, not the radius. Wait, what is happening? Let's look at that. Here it looks like the center is at 4. When I put it to 2.5, so this means that something is wrong in there, I guess. Maybe try 1. Let's try something. I mean, I'm just going to, because if we have to try to understand that way, it's going to just take much more time. Well, look at that, perfect. That looks like a lock to me. It's still kind of rust, you know, the line, it has a lot of points and empty dots. Is that looking good? I don't know, right? I'm not convinced it looks very good, but maybe we can make it a little bit less squared. -5 to 5, 5. Also it's a, oh, so it's 10 square coordinates. So what is, so it looks like it's a square of 10 actually. So it's a square of 10. So let's say on X we keep 10 and on Y we use 8. So we are changing all of the Y to 4. Something like this. And so probably we want to change that to 4. Maybe it will look a bit better. So anyway, now that this is correct, or almost correct anyway, first is that the color is not the same. Well, we'll make it look better later. It looks already not too bad. Not too bad. Not perfect, but not too bad at least. And then perhaps we should have, like, instead of a face, we could use something else. Maybe instead of a face we could use lines to draw the rectangle, and this way yeah, whatever. So the radius, we are going to reduce it a little bit to 3.5. And okay, so anyway, we are going to keep it like this. And now when the camera is cold, we want to change the rotation. So we are going to tell that. Maybe it has some clues about how to do it. ChatGPT, tell me. The drawing to always be facing the camera. For that I think in my camera callback we can update the rotation of the transform. However, I do not know how to get the rotation of the camera. So do you think it will get it? Camera orientation is by blah 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 in coin 3D, and consequently camera orientation is managed by the camera orientation field. Oh, that looks not too bad, but let's try. Is this the correct way, or is there a way for the logpad coin object to always be facing. Maybe there is a simpler way. Let's see. Ah, look at that. Isn't that great? A special transformation node called billboard. This type of node automatically orients the object it affects so that it faces the camera, no matter how the camera moves. So this is I had a feeling that this was something. Here's how you can integrate billboard node in your existing setup to make your logpad. Blah 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 blah. So billboard, set axis of orientation, log the orientation if necessary. So, but then we don't have a transform anymore. Or use the billboard here. Well, let's try that. I guess it's the cleaner solution. So if we can get it to work, it's going to be great. Where should I put that? Here maybe. And then we can add the billboard. So it adds the billboard before the transform. I don't know if it actually has like any importance. Probably, I would say. Logpad color, and you want to put the logpad color as the second one. Maybe there is a reason. Maybe not, but it costs us nothing, so we are going to do that. This we can close. Okay, let's go. Let's see, where is my square? Oh, wait, here. In set log position, translation, as no attribute transform. Well, let's see, 876. What? Set log position. Self, what am I doing? Self? In set log position, this was working before and now it's not working. Let me think. First we have maybe another issue here. Oh yeah, has no attribute, billboard. Is that something real? Maybe it just made it up. pv.coin has no attributes. Wait a moment. Where? Coin.billboard. Let's search the code base. Yeah, that's great. It just made it up. It just made it up. That's not a thing. That's not a thing. That's awesome. I mean that's incredible. Well, it's something sensible. I mean, if you told me it's something in coin, I would believe you, but it's not something apparently. So let us take this camera, rotation, orientation, get value. Let's try that. I think it might just work. You know. Camera, rotation equal grammar, blah blah blah, inverse rotation, blah blah blah. Let's try that and see what happens. If it works, we are going to be much closer to a working solution. Well, that doesn't work at all. Not even a little bit. and it's not giving us any error message, so we don't know what to do about it. I was hoping for an error message or something. Is it turning? Or is it fixed? Oh no, I'm not like perfectly. So yeah, no, it's moving. Look at that. Okay. So it is moving, but only when I change the zoom level. So if I move like this and I change the zoom level, you see it changes when I turn. No, it doesn't change when I turn, it only changes when I change the zoom. So if I change the zoom and then if I rotate and then change the zoom, then it updates. But then it updates to something that is wrong. So let us see. The camera callback, I'm attaching it to what? Camera sensor, field sensor, camera, camera. If okay, so I'm attaching to the camera focal distance. Well, this is annoying, and I still have an idea that there is something that would do like what ChatGPT mentioned. So I will pause the video for now and have a look. So yeah, so it appeared that it's actually like the version that ChatGPT gave us, it was inversing rotation before applying, and if we don't do that, then you see it acts correctly. It zooms, and then if we rotate, it also rotates. To get it to rotate it, not only when we changed the zoom level, I had to implement a second callback, because actually the camera sensor callback was connected only to the height of the camera, so basically the zoom level. So I made a second camera sensor which was connected to the orientation, and then it works okay. So now the problem is that it's not at the center of the object, right? So if I select this one, let me try to ground this one here. Ground. That's not correct. Okay. So well, that's actually at the center of the object. Oh, and look at that. Now it's at the center. So it's just that we are not initializing the transform. So we are going to change that. So in update data, we are actually doing, so, oh, that's a bad indentation. placement. So we want to be doing, well, let's first see if that solved the issue, because maybe it was just the indentation that was not correct, right? Let's see. No, it doesn't initialize where it should. But I don't understand. Okay, when I set the assembly as active, it recomputes. I think it recomputes the assembly, and by doing so, it positioned the lock at the correct placement. So, but anyway, we can set here create transform. When we create the transform, we can let me think, we can call maybe update data directly, and that will do something like this. Maybe not, wait a moment. So what we want to do is take this G-joint. Do we have G-joint in here? Yes, it's object. Here it's called object, so let's call that, yeah, never mind. Maybe I can just call it object here to keep things simple. So I will just take this and create a new function, def, and set transform, and it takes the object, self object, and then we paste that here. Let's see. Set lock position. So, well, actually, why I'm not putting this in set lock position? Let's take that, we put that here. Here we change, we don't take that anymore, we are taking object. We're taking the object as an argument, and then we just need to change, like, oh yeah, to have like pose equal plc.base. What am I doing? Well, why? Just why? Just okay, I don't know what's been happening in my brain. Oh yes, it was when it was in 3D, and you know, the 3D lock, we wanted to be aligned with the rotation of the object, but now we don't want that anymore, so we can just do something like this. Okay, and so here we do set lock position, and we give the object as an argument, so that should be okay. And so we are going to do this, right? We are going to do it here after this, like this. Okay, let's see. I think it should be okay now. I think it should be okay. Well, it's gone. Oh yeah, set lock position is not defined. Oh, right. Python, I swear, it should, in C++, it just, you write this, you will have like a red line telling you that's not correct, right? In Python, you're just like, yeah, you can type in whatever you want, it's going to be fine. And then you start the software, and oh, it doesn't work. Look at that. Still doesn't work. So view provide. What am I doing now? As no attribute. Oh, that's because it's already the view object. Alright, so I see. Oh, and that's going to be tricky. Well, not so tricky. So what is happening is that in this function, this is actually not the same object as we have here, because this is actually the view object, and so it's a bit misleading. So here maybe we can call that app object. So that's why initially it was written FP, because, well, let's keep FP as it was, I guess. And so here we want fp.view object. Wait a moment. No, it's not. It's not even view object that I want. It's object to ground. But then the issue that we have is that oh, that's so annoying. Let me see if I do something like this. We are going to make a small test. So O is assembly object, O.view object is the view object. Let's call that V equals. So V is the view provider, and now if I want to get back, maybe just, how do I get the object from the view object? Boring. I must have missed it. So how do we get the object from? This is so annoying. Wait a moment, because here, so we are passing the object to ground, and the thing is that, okay, let's give object to ground directly. Oh, let's call it grounded object. So grounded object is the feature, so the app object dot object to ground. And so if I go to because the problem is that now we are using this function in two places, right? We are also using it here. And this object is not what we want, right? This is the view object. So we have like, we want to pass this object to ground, and currently we have object. Object is actually like fp dot view object, and so this is not what we want, right? So I'm going to look here. I think at some places in join object I have like app obj. Well, apparently no. App obj equal view. Well, look at that, view dot object. Why is it not view dot object? Has no attribute object. Yet here it is doing it. So maybe it's only a feature Python thing. Oh yes, it's probably only a view. I don't know. v object. Okay, well, never mind. I know that I can, in attach function, if I do v object dot attach. So here I'm going to call that v object as well, because I think it's misleading that it's just called obj. So let's call it v obj. And so here v obj, and so basically we do v obj dot object, and then dot object to ground. And you know what? We can start the attach by checking that it actually exists, because maybe it does not exist. So v app object equals to this. Then we test the existence the same way here, like if app obj is none, or first if app obj is none, return if app obj dot object to ground. No, not that. Dot object to ground is none, then return as well. So we are making sure it is actually existing. Let's call it object grounded obj equals. What am I doing? Am I trying something? Okay, so here I'm making sure it exists, and so here we're just going to pass grounded object. Let's go. Look at that. What is it doing here? So now it's annoying. Set lock position. Well, I'm doing it here, so let's put a few things in here. If I click on recompute, nothing happens, right? Great. So anyway, get out. So let's see, here I'm print, so of course it should be doing it. Vector 0, 0, 0. Okay, okay. So why zeros? Let's see. Grounded joint. Oh, the placement is not 0, 0, 0. The placement of the grounded joint. And this is the placement of the grounded object. So it's the placement of this axis. And if you select this, you see the placement is not 0, 0, 0 either. So if I update. Yeah, it's not changing anything. If I activate the assembly, then it picks up the correct position. So it means that the object is not loaded when we are loading this object here. So instead of using, let's see, instead of using the grounded object, which is not mandatory. Oh, but it is because we are using this is for positioning. Yeah, because we want the bounding box center. Oh. Let me think. So the bounding box center. Yeah, it's because we want the bounding box center, and somehow this is not computed yet. Yeah, so this is not computed yet when this is called. And it might be because the grounded joint object is like loaded before this object. So we could be using the placement of the grounded joint, but then we are not at the center of gravity. Well, not even the center of gravity, but the center of the bounding box. See, there is a placement here that is saved, so we could already use that here. Yeah, it's not. So when this function executes, it is not yet correct. So, and the thing is that let's see, let us play a little bit in the so yeah, it's getting a bit boring now, this video, so maybe I will just, well, we are almost there, you know, so maybe we can finish it. So let's see. We want to play a little bit with the get bounding box function. So first I'm going to need an object. So let's say this object here. So in the Python console I'm going to do O equal that. So O is now an object, the assembly object to be exact. And so now we are going to get the view object of this. So the view provider that I'm going to call V. So V is the view provider, and now get bounding box. Get bounding box. And the problem is that this is not computed. And can we do something else with the bounding box? Calculate. Compute bounding box. FreeCAD Python compute bounding box. Oh. I want to see get bounding box, return bounding box, transform equal true, whether to apply the transformation matrix of this view provider. Default to active view. Well, so b dot, what do we have here? Is valid. Check if the bounding box is valid. So first we can check if the bounding box is valid, right? So that's annoying. That's annoying. You see how much time we are actually spending on things that are like kind of dumb. So let's first do something like this. bbox equals equal this first. If bbox dot is valid, then we use the center. Then we use this, right? And if it is not valid, then we can use maybe grounded objects. Dot placement dot base. Okay, so that's going at least to be better than nothing, but it's like it's kind of bad anyway. Oh, I can already see the issue appearing, right? Like, so now you see by default, if the bbox is not computed yet, it will put the lock at the origin of the object. Okay, so that's not too bad, but then you double click and it gets to the center of the bounding box where it is supposed to be. So let's see, now I want to lock this. Come on, what is that? So another small bug to fix: when it is created, it is actually not facing the camera, so we want to be calling this function here, callback. I don't know how to call that without any arguments. So we are going to add one function, which is going to be camera adjust rotation, lock rotation. Okay, lock rotation self dot. So then we just do self dot this, and here we do this. Okay, so that's fine. And adjust, and so we can call this function here, create transform. So after creating the transform, I think set lock position. So we are setting the position of the lock, and okay, and so we are setting the rotation of adjust lock. So we can just call that set, because, you know, for consistency, and here as well. Okay, let's build. So let's have a look. So now let's try to be a little bit faster, because we are coming on 2 hours, I think. Yeah, already 2 hours on that. So here the lock is correct. If I create a lock here, let's see, I create a lock. Yeah, it's correct. So now I need to remove this placement, this message. Yeah, I set no, not here. And we are printing something here. Yeah, we remove the message. Okay, so now it is working. You can select it, so that's a small bug to fix. Yeah, it's annoying. Why is it considering? And for the GCS it's not doing that, so okay, for the GCS it's not doing that, for the lock it's doing it. So I'm going to check what is the difference. Okay, and then the other thing is that now we want to remove this pad here, like this grounded symbol, this lock symbol. We need to remove it, right? So let's remove that. Where is it? So I'm going to copy that and just search for this symbol in all of FreeCAD, and so it appears here. On delete, remove the grounded tag. Well, we don't need to be doing that anymore. So I think we can remove all of that. Then here, in View Provider Assembly, remove grounded, can drag object, okay. Remove grounded tag if any, as it is done in object.byDelete. So all of that label, all of that is gone. And now in command create joint, we have two places where it appears. Here, remove the grounded tag, so this is gone. And here, object equals object.label plus. And I think that's it. Okay, so now we have to build, because I modified also the view provider. So we are going to build here. And then we are going to build so okay, and also I want to check for the dragger. You know, the issue it's that apparently get selected object within assembly is picking up wait, so we did this special movement. Where is it, like init move dragger? When are we initializing move dragger? So we are initializing if when we add to selection get selected object is true, with false and true. So get selected object, which is here, not adding pre-selection, and only solids. And so only solids, we are only checking that the subname is empty, like the element name is empty. Wait, so first let us check. So we are building also this module. Okay, building again, never mind. So this was to remove, okay, remove the behavior with the log symbols here. So that's, I think, well, it's not going to change the files that are already existing. So I can change like this, but if I create a new fixed joint, well, nothing is going to happen, really. Oh no, it's happening, okay. If I click again, disappear, appear, disappear, appear. So that's acceptable, I guess. And if I move that, well, it should not be able to move. If I solve it, will get back in position. So that's fine. That's fine. I think so. Here we are. The feature is, well, it's almost done, because when you click here, you should not be able to drag that. So let us fix this last bug, and then this feature will be done. Great. So view provider assembly and get selected object. So something is happening here. Yes, we said if the element name is empty, then it's accepting as a solid. And the problem is that it should not be accepting feature Python. And so get object from subnames is actually accepting. And what is troubling is that it's accepting grounded joints, but not like the normal joints. Get object from subname. So let's have a look at this function, and it must have something. So if derived from assembly objects, if derived from continue. So we are not accepting assemblies. If a part or body is derived from part design body, then we accept it. Well, that's weird, because we are not even accepting a part. What? How is that even working? Oh. If subnames. But I'm not even... I'm not sure I understand what... So my problem here is that I'm not dealing with the solids like part features. And I think I should be handling part features here as well. Actually, I should not be using part design body, I should be using part feature. Because of that, how can that even work if I select... Oh, that's a link. Well, no, it's a link, so it's the same thing. Let's take this one, for example. We put it here. So now we have an object, and if I select it, it still works. Even if it's not... Oh, okay. Let me show you how to break things, right? So you create a group, you put the assembly in the group. Where is it? It's here. So it should not change much, but I think if I click here, oh, it's still moving. Now I'm just confused. What is happening? Why is it accepting it if it's not... Oh, it's because it's the last one. Alright. Then it's neither a part, a body, or link. It's something like... But this is stupid, because I can just... And it's neither, blah blah blah, it's something like that. I can just here instead of body. Let me think. Part feature. The thing is that Yeah, because sometimes I look at the code and I see something that seems stupid, and I'm like, oh, that's stupid, let's remove it, and then it breaks something because I initially I implemented it for a reason, and I can't remember why. So here I think it's just that it's early code, and I could have done better. Say it's assembly.box.face. If it's browsing the subnames and not finding, well, I can still, yeah, so here instead of that, I can use part feature, and I think it will work just fine. Part feature, and if it is not a part feature, then because a part design body is derived from part feature, and basically every kind of solid, they are all coming from part feature. So this should be fine, because we are going from, well, I'm saying things, but I have a feeling that it's a bit cryptic. So let's see, and if it does not find, we can maybe return. Yeah, and so if this does not find anything, then we'll return nil pointer. And this way, I think, so get, where is this function called? If not object continues, so that's fine. Preselected object equal, yeah, I'm checking that it exists, so that's fine here. Well, so I think that's fine, because here we are just continuing, so we are ignoring things that are not solid. So let's see if that works in our case. Still, what was surprising is that it was not picking up the normal joints, but the grounded joints, yes. And so for this, I don't have really a reason. Well, let's see. I think the behavior should be gone, but maybe it's going to have broken something. So if I click on that, oh, yeah, you cannot even select it actually. So you cannot select it if it's not on top. So this is another thing that wait a moment, what do you mean you cannot select it if it's not on top? Like if I click here? Yeah, oh, great. Great, just great. I can still select it, and which is fine, I guess. Selecting it is not a problem. The problem is that it's putting the dragger, and it should not be putting the dragger. And on top of that, you cannot select it if it's like if it's not on top. Here you can select this joint, this one you cannot. So this is something to do with shape on top, something on that, like that. Yeah, set. So we have to have a pick style with shape on top. So self.pick. So we have to have self.pick. And we are adding that to the display mode, okay? And for consistency, where is it? It's just before the scene graph, so self.pick. And should we add that at a particular place? It's the first node here. Self.pick. Okay, and this self.pick, we are going to set it as like this, set the pick shape on top. Okay, so this bug is going to be fixed, and we still have the annoying issue that we were having before, and it was not fixed, so I don't even know why. So let me check that things still works in assembly for now. This works. You can select that. But here I don't have a body, so we have to try with a body to make sure it still works with a body as well. Let's create sketch. Let's make something like this. Close. Pad. Okay. Okay. So where is my body? Oh, it's already in the assembly, so that's good. Oh no, it's not working. Oh no, the assembly is not active. Okay. So that's still working. So you can still select it, right? Okay, fine. Sure. What day? Oh, we are Friday. Oh, I missed. I was confused, I guess. 1 hour. I missed the 1 hour mark. Well, never mind. That's just a small bug to fix now. Changing the pickability of this. So I will stop here. So if you have any comment like on the content, how I could make it better or so on, don't hesitate. Go on. Bye bye.